So it says find the domain of the function. We've got h of x equals x squared minus 25 over x squared plus 5x. So let's go ahead and write that down. H of x equals x squared minus 25 over x squared plus 5x. Hopefully you recognize that the denominator can be factored into x plus 5 and x minus 5 because it is a difference of perfect squares. And the denominator is x times x plus 5. Factor out the common factor of x. So let's talk about when the denominator equals 0. The denominator equals 0 when x equals 0 and when x equals negative 5. X equals 0, the factor just x, even if it was a 7x or whatever. If it's multiplied by just an x, then the 0 is always 0 of that factor. And then if it's not a shared factor in numerator and denominator, then that must be a vertical asymptote. Whereas this right here is a shared factor in the numerator and denominator, so we're going to simplify those out. And we're going to say that there's a hole in the graph at negative 5, comma, and then we write down what we're left with, x minus 5 over x, and we plug it in. Negative 5 minus 5 is negative 10, divided by negative 5, that's 2. And so there we go. We got a hole in the graph at negative 5, 2, and we've got a vertical asymptote at x equals 0, and the domain is therefore negative infinity, negative 5, negative 5 to 0, 0 to infinity. And there we go. Okay? If I asked you what is happening at positive 5, I would hope you would look and say, well, positive 5 is when the numerator and only the numerator equals 0, and therefore that must be an x-intercept. So we would have an x-intercept at 5, comma 0. And then, furthermore, just for kind of interest, if I asked you, what about y-intercept? Y-intercept is when x equals 0, yeah? It's when you cross the x-axis. Sorry, the y-axis is when x equals 0. So if I went to do that, and if I plugged in 0 into any of these expressions, I would get negative 5 over 0, I would get negative 25 over 0, whatever, I would get over 0, right? That's because we have a vertical asymptote at x equals 0. So if you have a vertical asymptote at x equals 0 on the y-axis, then there is no y-intercept. There is none. Okay? And I would expect an answer like that, not just a blank, but like none. Okay, let's write down k of x. K of x equals 2x squared minus 8 over x squared plus 9. 2x squared minus 8 over x squared plus 9. So let's look at that, or think about that. My numerator I can factor out a 2, and I'm left with x squared minus 4, and that's the difference of perfect squares, so I'm going to say 2 times x plus 2 times x minus 2. But let's talk about x squared plus 9. X squared plus 9 is not a difference of perfect squares, it's a sum of perfect squares. Sum of perfect squares, if I set x squared plus 9 equal to 0 and tried to solve, I would get x equals plus and minus 3i, because I'm taking the square root of a negative number. Those are imaginary, so I could say x plus 3i and x minus 3i, but those are imaginary, which means the denominator never equals 0, which means there are no horizontal asymptotes and no, dadgummit, Jennifer, no vertical asymptotes. We do have a horizontal asymptote. We'll talk more about that later, but we do not have a vertical asymptote, and we do not have any holes in the graph because the denominator never equals 0. So what are negative 2 and positive 2? They're x-intercepts. So it's where it either touches or crosses, well, it crosses the x-axis. So there you go. Okay. Let's look at, so what would the domain be? The domain here would be all real numbers, or negative infinity to positive infinity, because the denominator never equals 0. We've already talked about that. So let's go to here. X and y intercepts, I already kind of mentioned that. We've already been talking about it. So just as a recap, x-intercept is, oh gosh, sorry. It's some number comma 0, right? It's when y equals 0. So when you think about the function, f of x equals some expression in the numerator and some expression in the denominator, the only way that the y value, which is the function, the only way that this equals 0 is if you got the numerator equal to 0, right? So a number divided by 0 is the only way that you get 0. Oh my gosh, wow. 0 divided by some number is the only way that you get 0. So if the numerator equals 0, then you have 0. Well, what you have to remember to do is factor out any common factors, like simplify those out, numerator and denominator, because those are holes in the graph, not x-intercepts. And then once you're done with that, it's only with the numerator. So say I had x plus 7 times x minus 4 over x minus 4 times x plus 1. Well, these equal 0 at the same time, 4, so there's a hole in the graph, but then the numerator equals 0 at negative 7, and only the numerator equals 0 at negative 7, so that would be an x-intercept at negative 7 comma 0, whereas 4 would be a hole in the graph. Okay, so y-intercept is 0 comma some number, so this one actually is even easier. This is when x equals 0, so literally that just means, so say I had a rational function h of x over m of x, right? If I want to know what the y-intercept is, I just plug in 0. So h of 0 divided by m of 0. If x equals 0, just plug in 0. Whatever I get is the y-intercept. So if I had x squared plus 3x minus 9 divided by 2x plus 4. If I plug in 0, I get 0 plus 0 minus 9 over 0 plus 4. The answer is negative 9/4. So I can just take it as the constants. You're not guaranteed an x-intercept, and you're not guaranteed a y-intercept. You could have a rational function that has no intercepts, and that's okay because it's got vertical and horizontal asymptotes at the axes. But if they are there, this is where you'll find them, and this is where you'll find them. Only numerator, and then constants only. Could be 0, but that would already have been found. All right, I'm going to do one more problem on this, and then I'll pick, well, no, I'll do these two, and then we'll do the last video. Find the domain, vertical asymptotes, holes, and intercepts of the given function. Okay, so pause it and write this function down. 2x squared plus 3x minus 14, all divided by 5x squared minus 5x minus 10. The numerator doesn't have any common factors, so I'm going to go ahead and say, what are the factors of negative 28 that add up to positive 3? And so 7 and 4, negative 4, divide by 2. Yeah? So 2x plus 7 and x minus 2. 2x squared minus 4x plus 7x minus 14. Good. The denominator I can factor out of 5, and I would be left with x squared minus x minus 2. And the factors of negative 2 that add up to negative 1 are negative 2 and positive 1. So, first off, domain. Domain is everywhere the function exists, which is everything but when the denominator equals 0. So x equals 2 is out, and x equals negative 1 is out. So negative infinity, negative 1 to 2, 2 to infinity. Okay, vertical asymptote. Vertical asymptotes occur when the denominator and only the denominator equals 0. So as far as factors go, x plus 1 is not repeated in the numerator and denominator, so that has to be a vertical asymptote. Okay. Hole in the graph. Holes in the graph occur when, I checked it before doing it, when you have a shared factor in the numerator and denominator. X minus 2 is a shared factor, which means there's a hole in the graph at 2 comma something. So I'm going to write out what's left, 2x plus 7 over 5 times x plus 1, or 5x plus 5. And I'm going to plug in 2. So I get 4 plus 7 over 5 times 2, so I get, 5 times 3. 11/15. Okay, so we have a hole in the graph at 2 comma 11/15. And lastly, we have intercepts. So let's talk about x-intercept. X-intercept occurs when y equals 0, and so that's when only y equals 0, right? So x-intercept is when the numerator and only the numerator equals 0. So my numerator equals 0 at negative 7 halves. It also equals 0 at 2, but that's already a hole in the graph. So this right here, my x-intercept would be negative 7 halves, comma 0. And then my y-intercept is when x equals 0. So when x equals 0, I can, like those are gone, I can plug in x equals 0 right here, and I could say 2 times 0 plus 7. So 0 plus 7 is 7. And then 0 plus 1 is 1 divided by 5, right? So I could say 7/5. But I could have gotten that, and I would prefer you get it from the very beginning. Y-intercept, I always just go back to the original form, not factored, because it's even easier. If x equals 0, everything with an x is gone, and I'm left with negative 14 divided by negative 10, which is positive 7/5. And there we go. Okay, so last video coming up.